7.5 is on properties of radicals. We learned how to work with square roots before, but now we're going to learn how to work with any type of roots. This x is an xth root, meaning it could be a third root or a fifth root or a 12th root, whatever. But we have these properties of radicals we can work with when we're simplifying. For example, if I was doing the third root of 5 times the third root of 7, that becomes the third root of 35. 5 times 7 is 35. And if I was doing 2 times the fourth root of 80 times 3 times the fourth root of 12, well, this gets pretty messy pretty quick, but you can kind of pair things up well. I just do 2 times 3, which is 6. And then I'm going to do inside the radical 80 times 12 is 960. So the stuff in front multiplies, the stuff inside multiplies, and I'm going to simplify this 960. 960 is 96 and 10. That's an easy place to start. 96 is 48 and 2, 24 and 2, 4 and 6, 2 and 2, 2 and 3, 2 and 5. Okay, I'm doing a fourth root here. Since the fourth root of our groups of 4, there's 1, 2, 3, 4 2's that come out and multiply with the 6 that was already here. And then this 3, and this 2, this 2, and this 5 stay behind. So it's 3, 6, 12, 60. So it's 12 times the fourth root of 60. That is how this original problem simplifies. The moral of the story is if you have the same root, you can multiply anything. If I was doing like the third root of 7 times the fourth root of 9, I can't do that right now. We'll eventually learn how to do that by using fractions, but for now we're just leaving that alone. If the number inside the radicals are the same, so for example, I'm doing this rule now, if I have like 3 times the fourth root of 2 plus 9 times the fourth root of 2, these right here are like terms. It's like we have the exact same variable, only this time we have the fourth root of 2, which I don't know what it is, but it's the fourth root of 2. So I add these up, and I get 12 times the fourth root of 2. Sorry I wrote that like a crazy person. 12 times the fourth root of 2. If I have 3 times the fourth root of 5 plus 3 times the fourth root of 6, that's already simplified. I can't do anything else with that. Because this number and this number have to be the same, and this power and this power have to be the same whenever you're adding. A nice rule, this can actually go in either direction, but one that can make simplifying problems really nice, is I can take one big radical and break it into two little ones. So you've seen me do like the square root of 25 over 16 is really the square root of 25 over the square root of 16, which becomes 5 over 4. But if you ever wanted to, you could do them the opposite direction. If I had the square root of 2 over the square root of 8, I can write that in one big radical, which I can reduce. And then the square root of 1 is 1, and the square root of 4 is 2, so the square root of 1/4 is a half. Now take those properties and kind of play with them a little bit. Square root of 98 is 2 and 49, we have 49 and 2. 49 is 2 7s, so this becomes 7 root 2. 32 is 2 and 16. 16 is 4 and 4. I can just grab this pair of 4s and bring it out. Even though those 4s aren't prime numbers, they are a pair, so I can pull it out right now. I have 2 times 4 root 2, because it stayed behind. This is 7 root 2 minus 8 root 2, which is negative 1 root 2, or just negative root 2. 375 is 125 and 3. 125 is actually a 3, 5, so you get 25 times 5, and 5 times 5. So this is actually going to reduce, use a triple that comes out into 15, because it's this 5 times this 3. 15 times the third root of 3. 81 is 9 and 9. So there's 4 3's here, so a triple of 3's comes out and multiplies this 5. And I get 15 times the third root of 3. These can combine to become 30 third root 3. I'm going to multiply. I think multiplying is actually much easier. I just multiply the stuff on the outside, 12, and the stuff on the inside, 140. Then can 140 break down? There's definitely a 4 that can come out of here. I'm going to find fractions of 140, which I already know can start at 10 and 14. You can always start here at 14, or 140 is 10 and 14. 2, 5, 2, 7, and then the pair of 2's comes out. So these pair of 2's multiply this 12, and I get 24 root 35. This stayed behind, and this stayed behind. So for a third root, because this is an odd root, remember the negative can just come straight out. So I'm going to multiply everything first. I'm going to have 15 times the third root of negative 12 times 86, whatever that is. I don't actually know what that is. I'm just going to leave it times 12 times 18, actually. I said 86 times 18. A times a squared is a to the third. B to the fourth times b squared is b to the sixth. The reason that I left this way is because I'm going to do a factor tree anyways. If I had calculated 12 times 18, well, 12 times 10 is 180, 2 times 18 is 36, would be 216. If I had calculated the 216, I still would have factor treed to 12 and 18 anyways. So I can sort of save that time. I'm doing a third root, so we need triples, and there's a 1, 2, 3, there's a triple, and there's a 1, 2, 3, there's a triple. Everything actually comes out of that root, nothing stays behind. So I'm going to pull out the negative. I have negative 15 times 3 times 2 times the third root of a to the third, b to the sixth. Negative 15 times 3 times 2 is negative 90. A to the third, I take the power and divide by 3, and I get a to the first. I take 6, divide by 3, I get b squared, and there's nothing left inside that radical in this case. Everything came out because everything ended up being a perfect cube. Add more? Nope. It's worth going on like this. Let me see what else we have today. Yeah, okay, we'll just finish this up. This needs to be FOILed. It's a binomial times a binomial. I think these are getting more and more hairy as we go. So I do the top, I get 12 root 6. 4 times 3 is 12, and 3 times root 2 is root 6.
Good morning, staff. A Wednesday morning reminder that prayer will be happening in the chapel at 7:30. We welcome all of you to be there. Thank you.
I'm missing prayer for you. Hope you understand how much of my life you take up here. This becomes 15 root 4, and this becomes 30 root 2 minus 30 root 2. So now I simplify. That can't simplify, and that can't simplify. But the square root of 4 is actually just 2, so that's really just 30. 15 times 2 is 30. So I'm going to have 30 plus 12 root 6 minus 24 root 3 minus 30 root 2. You don't have to list those in any particular order. I apparently went in that order, but sort of whatever. That's the foiling that takes place there. Last thing to worry about, when you are having radicals on bottoms of fractions. Well, we don't like that. And just like we did with I, remember when we had something like this? We would multiply by this. We would take the number on the bottom and just flip the sign of that term. I do the same thing here. I multiply by 1, but the one that I pick is called the conjugate, where I take the bottom and I just flip the sign. I flip whatever that sign is. And I do that because the foiling on the bottom works out really nice. So on top, first of all, I distribute. I do 2 times 5, which is 2 root 5, and 2 times 1, which is 2. On the bottom, I do root 5 times root 5. You will get faster at this. Root 5 times root 5 is root 25, which will just become 5 in a second. Root 5 times 1 is root 5. Negative 1 times root 5 is negative root 5. Negative 1 times 1 is negative 1. So on top, I still have 2 root 5 plus 2. On the bottom, I have 5, because this is just 5. These two things cancel each other. Root 5 minus root 5 is 0. So I have 5 minus 1. This ends up being 2 root 5 plus 2 over 4. Now remember, I look at each term. That can divide by 2, that can divide by 2, and that can divide by 2. Since everything can divide by 2, I can divide everything by 2. The thing inside the radical never gets divided, it's just a coefficient in front. Basically what I'm doing, I'm getting root 5 plus 1 over 2. And basically what's happening is here I'm pulling a 2 out of the top, I'm pulling a 2 out of the bottom, and these 2's are canceling. That's giving me that. So if you could take a second and try this one, that'd be worth your time, but I'm going to speed through it now. On top I get 18 minus 3 root 3 plus 6 root 2 minus root 6. On the bottom it's always this number squared minus this number squared. So I have 18 minus 3 root 3 plus 6 root 2 minus root 6 all over 33. And even though almost everything here can be divided by 3, this term here does not have a 3 in it anywhere that I can pull out. So there, that is simplified. I believe that takes care of that. A bunch of examples. One more. Multiply by the conjugate, which in this case is just going to be root 11. I get root 110 over 11. Basically, it's like I have this, and then multiply it by this. So it's just going to come up to this in a much faster fashion. Thank you.